Here we go again. We're going to battle it out between the categorical variables and the quantitative variables. Let's first consider height. In this situation, we can think about the first individual as someone that is taller, and the second individual as someone is shorter. In this situation, height will fall under categorical variables because we're talking about different types of groupings without any numbers involved. If we want to now talk about height as a quantitative variable, we'll give numbers to the person's height. In this situation, we can say the first person would be 6 feet 2 inches tall. We'll say the second person is 4 feet and 11 inches tall. Since we're talking about height with values instead, 6 feet 2 inches and 4 feet 11 inches, it will fall under quantitative variables. Now let's look at age. So we can have age as older or younger as categorical variables. If we want to answer the question how old someone is, this will end up being a quantitative variable because we're going to end up giving numbers. We can say the older person has the age of 70 and the younger person has the age of 30. Now let's look at grades. If we think about grades, we can receive grades as A, B, C, D, or F. These will all fall under the categorical variable. In addition, we can simply just say a pass or a fail for our grades. This will also fall under categorical variables. If we want to think about quantitative variables for grades, then we'll think about what we received on a quiz or a test in terms of a percentage or points. So if we have 50% on a quiz or 100% on a test, now let's go over one that's a little bit more tricky. If we have a restaurant, we can rate the restaurant between 1, 2, 3, 4, and 5 stars. So just rating them between stars, although we can rearrange them as 5, 4, 3, 2, 1, or if we even felt like it, we can arbitrarily rearrange them as 2, 4, 1, 3, and 5. These will still fall under categorical variables. If you're still not convinced, let's think about writing these arrangements as a different type of opinion, starting with strongly disagreeing, and then moving down from disagree to neutral or agree, and finishing off with strongly agreeing. Hopefully we can see that if we just think about them as ratings from strongly disagree to strongly agreeing, that these ratings still fall under categorical variables. Even though we can assign numerical values to them, they still are a category based on opinions. If we wanted to, how can we use rating as a quantitative variable? One thing we could do is to take the values of the rating and calculate some kind of measurement. The most common one would be arithmetic mean. We will do this by taking up all the values, adding them up, and dividing it by the number of values. So, for example, let's just say our first patron rated 3 stars, our second patron rated 4 stars, our third patron rated 5 stars, and our last one rated 2 stars. If we wanted to calculate the average or arithmetic mean, we will add up all four values, 3 plus 4 plus 5 plus 2, and divide it by the number of values, which will be 4. This will give us 14 over 4, and we will convert this into decimal form of 3.5. So our measured average or rating here would be 3.5. And that's how we can think about it as quantitative values. Although we have deliberately chosen examples that have both categorical and quantitative variables, however, as we learn more about variables and their subgroup, we will find out that many variables do not have both types. Okie dokie, time to look at the subcategories of categorical variable. We have ordinal, nominal, and binary. From our examples from before, only grades as pass or fail are binary, and the other three are ordinal. Let's figure out why based on its definitions. So for ordinal, groups that are ranked in specific orders will be considered ordinal. So the most common type of these would be places, as in first place, second place, or third place. Typically, we expect first place, second place, or third place to have significantly different types of outcomes, especially when we think about monetary outcomes. Let's continue with nominal. So nominal refers to groups with no ranking or order between them. The most common one we might think about is color. So we can have blue, green, or red. Or if we decided to rearrange them as red, green, or blue, this doesn't really have very much meaning when we're regrouping these things. So this is one reason we have nominal groupings, where rankings don't actually have very much meaning to them. Other examples include species names and brands. For binary group, we think about the prefix bi, like bicycle, where there's only two things possible, a yes or no outcome. Sometimes we call this a dichotomous outcome. So the most common one we can think about is pass or fails. Other examples include coin flips when we have heads or tails, or results of games, in particular maybe football games when we have wins or losses. And those are our subcategories of categorical variables. Time for quantitative variables. In quantitative variables, there are two subcategories, discrete and continuous. Funny enough, the examples we went over are all examples of continuous. And let's figure out why from the definition. When we're looking at discrete variables, we're thinking about counts of individual items or values, in particular integer values, or other whole number values. Common examples include the number of students in a class, number of different tree species in a forest. Other examples we can consider are like cars on the lot. We can count the number of blue cars on the lot, the number of green cars on a lot. Okay. In either situations, when we start counting the number of cars on a lot, we want to consider that fractions don't quite make sense. So having half a blue car doesn't quite make sense for counting the number of cars. When we talk about continuous variables, what we're going to look at are the measures of non-finite values, typically ratios and fractions, or values that can take on values with a given range or interval. If we take an algebraic approach to looking at ratings and think about it as domain values, then we can say, hey, our average rating can be any number between 1 and 5 inclusive. Similarly, when we're looking at our grades, it can be any percent between 0% all the way up to 100%. How about age though? Age is an interesting one because when we're looking at age, we're thinking about whole numbers. However, if we're looking at age for a newborn baby, we can think about age in terms of hours, like 3.5 hours or 3.5 hours. Or how about we think about toddlers of 14 months? Then if we're thinking about 14 months and we convert this to years, we can think about something like 1 year, 2 months. So that'd be something like 1 and 2 over 12, or we'll have 1 and 1/6 of a year old. Other common continuous examples include distance, volume, and weight. Huzzah! That's categorical and quantitative variables and their subcategories. Like and subscribe. But next time we're going to talk about categorical graphs, bar graphs and circle graph in particular, and quantitative graphs, histograms and scatter plots. And eventually we'll talk about the difference between bar graphs and histograms.